Hello, myself Yusuf. Welcome to the video about tall building design in ETAPS. We have to use four different plans for four different types of story, and we have to provide three types of beam and three types of column having concrete grade of M40 and HYSD 500 reinforcement bar. We have to provide 150 thickness of slab of concrete of grade M40. Dead load and live load we have to apply it as per given in the figure, and window parameter is considered in Vadodara. You can see I have already created the model. I have used building setting, display unit, metric SI, steel section database Indian, and steel design code IS 800 2007 and concrete design code IS 456 2000. Very first part of the any model is material properties. I have defined material properties HYSD 500, masonry, M40 grade of concrete, and MAL 250 of rebar category. Now, second part is define the section property in which frame section is beam and column is created. I have used three types of beam and three types of column. In this beam, I have used depth of beam 500 mm and width of the beam 300 mm, and material is M40 grade, and reinforcement bar is HYSD 500, and cover for top and bottom both 30 mm cover is provided, and M3 design only is created for the beam. Same for both beam. And now for column, I have used three types of column: 500 square column of 500 mm, 600 mm, and 550 mm of M40 grade concrete, and reinforcement is HYC 500, clear cover for confinement 440 mm, and design type P M2 MC design. Rectangular column reinforcement is also rectangular ties I have to use. Now I also used auto beam and auto column for both column and beam. In auto beam, I have to select three types of beam: beam 500 into 300, beam 550 into 350, and beam 600 into 400. And same as for auto column. Now we have to define the slab section. I have defined slab of 150 mm thickness having modeling type shell thin and slab material M40 grade. Then I have defined wall section of wall 230 mm thickness. Masonry material of wall is masonry, thickness 230 mm. Okay. Now second part is how the components of the building is drawn. For easy understanding, I have removed one column, one beam, and one slab each to show how column, beam, and slab is drawn. Now first we have to draw a column. This here we have select auto column and similar story. Now second is we have to draw a beam. Quick draw beam, select here select auto beam and draw beam here. Now for drawing the slab, draw floor, wall object, quick draw floor. Here select slab 150, then the slab is created. Now define the load patterns. Here dead and live is already in there, and we have to create wind load and superimposed dead load, means cladding. In wind, so for creating wind load, we have to type wind, and here select wind and IS 875 2015, and in the create and add new load, and select wind and modify lateral load. Here select exposure from shell object. I have used location Vadodara for which wind speed is 44, carrying category 2 important factors 1, and here click on OK and superimpose dead load. Means here type which you give name cladding. I have given name superimpose SIDL, and here select super dead and click on OK. Now next step is assign support. Here we have to provide joint as restraints and select base. Here okay, click on OK. Now I have already given loads on whole building, but I have removed some part, means slab in this column and one beam. So for this I have to give load. For slab we have to assign load, shell load, uniform, and in this we have to provide a dead load of 2 kN and live load of 5 kN per meter square. So here select dead load 2 kN per meter square and click on apply. Now you can see that I am already given the 2 kN dead load for all. So here you can see 222 in whole part. Now I have to give live load. This live load value is 5 kN per meter square. So here select live load and 5 kN per meter square and click on apply. Okay. Now we have to draw a cladding. For this we have to draw, select auto draw cladding and select use floor and click on OK, so that here all the walls are created. Now we have to assign cladding load on beam which I the beam which I have removed. So select that beam, assign frame load distributed, and value is 0.8 kN per meter. Here select SIDL and click on apply. Then OK. Here you can see the all periphery beam have given SIDL of 0.8 kN per meter. We have to apply wind load on wall. For this we have to go into elevation, section A. Here you can see the section A and select all similar all story. On this and apply, assign shell load, wind pressure coefficient. For windward side, wind pressure coefficient for our building is 0.8. So I have to put 0.8 on windward side and click on apply. Now here already applied. For this side, we have to use point minus 0.25 here. Then we have point minus 0.25 and click on lever. Same for sides. For side C and D, minus zero point 0.8 and minus 0.4 for both. So here we have to write minus 0.8 and here select lever or side and click on apply. Here I have already given, so no need to repeat.
Next step is define the load combination. Here load combination, I have already added the default design combos and click on OK. And next step is to analyze the building. So on analysis,
Now analysis is a bit a long process, so I skip the analysis in a part.
so we have to go now display, model, 3D view, display and deform shape.
How the building deform due to loading, shear force and bending moment diagram of each frame element and shell and stresses in the slab. Now next part is design. First, okay, design, concrete frame design and start design and check. Here to check all member pass design or not, we have to go concrete frame design, verify all member pass, all concrete frame pass the design check. Now we have to see design detailing of element of the concrete frame, display design info, longitudinal reinforcing, apply. By right clicking, we can see all full design of detail this moment and shear. The reinforcement with shear reinforcement required, torsional reinforcement required, and required rebar, top rebar and bottom rebar required. We can see this. We can also get the design detail of the column. For this we have to go on elevation, A, here we have to go on details, column 500 by 500, DNH, design load 625 kilonewton, moment 68, 71, rebar area 2000 mm square, percentage 0.8, maximum allowed is 4% for rectangular column and 6% for circular column. And other details, we can also get flexural details, shear details, joint shear BCCI details, and envelope. It is one type of summary. Interaction curve we can also get from this, which is used for calculating which is used for manual calculation for column having biaxial and uniaxial moment. Okay, so here is the completion of our tall building design project. Thank you for the watching.